Okay, so this is our last set of examples, our 1.3 examples for Chapter 1. So we'll dig a little bit deeper into how to use the calculator and some of our one-variable statistics, and also what some of those values mean. So here we have the data on the amount of fat in 9 different McDonald's fish and chicken sandwiches, along with a stem plot. Okay, so they give us the types of sandwiches that would be categorical data, but we're interested in the numbers. Right? So when I look at my stem plot here, this 0.9, that represents the premium grilled classic chicken sandwich, right? This only has 9 grams of fat. This 1.4 corresponds to the crispy ranch sandwich, and so on. So we have the stem plot over here, and then the raw data here. So the first question is to find the mean amount of fat for the fish and chicken sandwiches. So first thing I'm going to do is open my calculator. And remember, where I want to go to on my calculator here is I want to press the stat key. I'm going to press my stat key. And the first thing I have to do is edit. I have to get those grams of fat numbers into my calculator. So right now I have a list of numbers in there from a previous exercise I did. So I want to go up to the top here so that L1 is highlighted. Notice how I highlight L1 first. And now what I do is I press clear. So now when I press clear and I arrow down, that list is empty. And now I'm able to enter those values from the example. So if you want to pause the video for a second while you get all those numbers entered in, and then just double check them. Okay. So I think I've shown you this before, but we can calculate the one variable stats for that data. So we're going to press second and mode to quit and exit out of there. We don't need to see the data at the moment. Or you could probably just go right to stat, calculate. Okay, so it's the stat key and then right arrow over to the calculate menu. And I want to calculate one variable statistics. So again, if it doesn't automatically give you this pop-up menu with L1 selected, just go down to calculate down here. Okay, and maybe your screen looks like this. Just if you have an older calculator, I'm going to say one variable stats, then you're going to press second and the number 1 for L1 so that it looks like that. And our very first number here, X bar, that is our value for the mean, 19.88 or 19.9. So I would answer the first part here with 19.9 grams. I want to make sure I label my units here. The premium crispy chicken club sandwich is a potential outlier. How much does this one sandwich increase the mean? So premium crispy chicken, let's see if we can find that. Chicken club. Premium crispy chicken club. Premium crispy chicken club right here. Okay, so I want to take that 33 out and then recalculate the mean after that's been taken out. So if I go back to my calculator and I go to stat and edit, I can go down to that 33 and just delete it. Okay, now we can quit, and if you want to, just hit second enter. Second enter will bring up my last executed command. It's just a shortcut. Recalculates it, and I get 18.25 as my new mean. So how much does it increase it? Well, we would just take 19.9 minus 18.25. So for part B, it increases 1.65 grams. Okay, notice I answer both of those with grams. Try to avoid just writing out numbers without any context. So now we have the same data, just listed in order, and we can see our median value is going to be 19. That's the middle number. Now we'll scroll down to the next example. These are the B. And what we'd like to do here is make a stem plot and then also find the median. Okay, and they're saying find the median by hand, which we'll easily be able to do, but I'm still going to, even though I want to find the median by hand per se, I'm going to use the calculator to help me out, and I'll show you what I mean. So the first thing I want you to do is take this list again. All right, you're going to go to stat and edit again. This is all good exercise for us to get familiar with the calculator. Go to the top of this list, so L1 is highlighted, press clear, and now we're free to put a new list in that calculator. I want to put this new list of values from the beef sandwiches in my calculator. So remember what they wanted from me was a stem plot. So it would be really hard to just start creating a stem plot with the data presented the way that it is. So what I want to do first is sort that list. So I'm going to quit out of here, okay? And we almost go to the stat menu again, but this time I'm going to hit second and the stat key. See how in the stat above stat in blue is list? So I'm going to hit second stat for list options. And I have the names of the list. What I want is an option, and I would like to sort these numbers ascending. I would like them to sort them from the lowest to the highest. So I'm going to arrow over to the options, press enter, and I'm going to hit second and the number 1 here so that I tell the calculator to sort L1. So it doesn't really appear that anything has happened, but now when I press stat and edit, my numbers are now sorted in order, which I think is going to be really, really helpful to us. So let's write those down in order. On our paper, we have 9, 12, 19, 23. So I just double checked my list. So my stem here is going to be my tens digits unit. So I'm going to start with 0 tens, all right, 1 10. These will be my 20s. These will be my 30s, and these will be my 40s. Okay, so the sandwich with 9 grams of fat is going to live right here. That's just the basic hamburger. And now I have a couple that'll go off this next stem. So we have 12 and then 19. Okay, cross those off. Then I go into the 20s. I have a sandwich with 23 grams of fat, 24 grams, 2 sandwiches with 26 grams, 1 with 27 grams, and 2 sandwiches with 29 grams. That's where most of my data lives, in the 20 grams of fat. Then we have a sandwich with 31 grams of fat and a sandwich with 43 grams of fat. Okay, so I have 12 numbers. How do I find the median or the middle number? Well, I can use my stem plot, right? And we can count 1, 2, 3, 4, 5, 6. So this is the dead middle of my data. Don't put that in your stem plot. 1, 2, 3, 4, 5, 6. There's 6 numbers below this point and 6 numbers above this point. So what is that point? It's 26 grams of fat. I would just average these 2 numbers, but they happen to be the same number. So the median is 26 grams. And my key down here at the bottom, if I were to make a key for this, which if you're going to make a stem plot, that's always a good idea. I didn't mean to erase that whole thing. Okay, but if we put a key down here, we put 1, 2 equals 12 grams of fat. Okay, that would explain to somebody that's reading the stem plot what the stem and leaf plot means in terms of value. So our next example, we have the fish and chicken sandwiches again. We already identified the median. Now we're talking about the Q1 and Q3. So when we divide the data in half, right, this list of numbers here has an odd amount of numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 19 is the median. So now the bottom half of the data is 4 numbers. So Q1 is the median of that bottom half. So that's why Q1 is 15. It's the average of the 14 and 16. And then finally Q3 is halfway between 22 and 27. And we've calculated that as well. Okay, 22 to 27, halfway between that would be 24.5. So our question here is to find and interpret the IQR. Well, the IQR is 24.5 minus 15. It's already been found for us, right? The IQR equals 9.5 grams of fat. Now, that's not an interpretation. For an interpretation, what would that look like? Let's think about our interpretation. This means 50%, or the middle 50%, okay, so this is your middle 50%, right? 25% of the data has less than 15 grams of fat. 25% has more than 24.5 grams of fat, or 24.5 grams of fat. But middle 50%, it's a measure of spread, right? It's the middle 50% has a range of 9.5 grams of fat. If you're thinking of a box plot, I don't think we made a box plot of this data, but what we're talking about here is the width of this portion. And when we have values that are outliers, if we have a really large value, that would make the range really, really high, right? A really large value will stretch the range, but it won't affect the IQR. The IQR is a little bit more resistant measure of spread, just like the median is a more resistant measure of center. Okay, so I'm going to do this. We could do this two ways. I'll do it both ways, just to sort of assist you here. But these, I think we still have these amounts in our calculator. Let me just check. Stat and edit. 9, 12, 19, 23, and so on. Yep, 9, 12, yep. I think it's the same numbers. So if I want to do this the really quick way to see if there's any outliers, remember we're going to just graph it. We'll let the calculator do the heavy lifting for us. I'm going to hit second and y equals. Okay, plot 1 is turned on. All right, and I'm going to drop down here and go over to the modified box and whisker plot. And now my shortcut, quick way to get the graph is to just press zoom in 9. Okay, and we can see we definitely have an outlier here. All right, so we could make the modified box plot with our calculator and at least know for ourselves that there's definitely an outlier. Or if we did this by hand, we have 12 values. We know this is the median right here. And in fact, we already calculated the IQR, right, in a previous example. Remember, the IQR is 9.5. So remember what we do with that IQR. We multiply it by 1.5. So I take 1.5 times 9.5. And that's 14.25. Okay, so that's that elongated measure. Now, what was my Q3? Remember, my Q3 was 24, or my Q1 was 15. Okay, so I just realized this is not the IQR from the previous example. So let's go back to our calculator. I'm going to look at the graph here. I'm going to use my trace button. And my IQR, my Q1 is 21, and my Q3 is 29. Okay, see 21 to 29? And I'll show you that on paper. Okay, Q1 was 21. He lives right here in between these two. And then the Q3 was 29, right in between these two. Remember, this is the middle of our data, right? So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 numbers down here. So this is 21. Q3 is 29. So sorry about that. The correct IQR here is 8. So now I'm going to take that IQR and multiply it by 1.5. That's 12. So now I'm going to take 21 minus 12. Okay, and I get 9. Right? So 9 is in the list, but anything that falls below 9 is going to be an outlier. All right, I took my Q1 minus the 1.5 IQR. Now I'm going to take 29 and I'm going to add 12 to it. What happens when I do that? Okay, so this is 41. So if I have a number that lives above 41, and indeed I do, I have 43, that would be an outlier. Okay, so that's the 1.5 IQR rule. But remember, you can use the calculator as a backup to kind of help you identify if there's an outlier. Okay, so here we have the number of home runs hit by Hank Aaron in each of his 23 seasons. Let's make a box plot of that. So let's let the calculator take away some of the heavy lifting here. We're going to go to Stat and Edit. And again, let's clear our list. I'm going to come over here, get to the top. So L1's highlighted, press clear, and we drop down. So take a couple of minutes and enter that list into your calculator. Okay, so once I get those that list of numbers in the calculator, remember we're going to go to second y equals. Okay, stat plot is already on. It's already configured. We already just did this, but in order for the calculator to know that you changed the list, you're just going to want to press zoom 9 one more time. So now we have a new box plot. Right? This is Hank Aaron's home run. It's a description of his graphic description of his home runs over his 23-year career. So now when I hit trace, this is going to be important. I want to see the minimum number is 10. I'm going to do the best I can to scale this out when I draw it by hand, right? So I want to go from 10 to 26. So if that's a difference of 16, then when I draw this by hand, from 26 to 34, that's only a difference of 8. I wouldn't want this distance here to be the same as this. I'd want it to be about half that length, right? So it makes sense. I go 16, and then I only go 8, and then I go another 10, so that's a little bit bigger, and then I have a real short tail at the end here up to the 47, okay? So I want to recall what that 5-number summary is: 10, 26, 34. Let's write them down. So back here, 44, 47. Okay. And if I were to describe the shape of this distribution, right, let's think about what would we call that shape. Well, if there's a long tail to the left, it's a skewed left distribution. This means that if we compared the mean and the mean is probably a little smaller than the median. Okay. So now I'm going to take those numbers and I'm just going to sketch them on paper. Right? If this is for me or for an AP exam, right? Our min is 10, and then it jumps to a Q1 of 26. So I just have to be consistent in my measurements here. If that's a jump of 16, and then I'm going to go from 26 to 34, let's make that jump about half that much. And now this next one should be about the same as that, but a little longer. But I'm not going to measure with a ruler or anything. So that's up to 44, and then a really short tail here up to 47. Okay, and we would label this home runs. Right? These are Hank Aaron's home runs in his career. So you can see, a typical measurement of his home runs would be more like 34. We probably wouldn't want to use his average number of home runs because it's taken down by this number 10 here, which could mean a lot of things. It's not an outlier, but it could, this could be his first couple of seasons. But in general, over the course of his career, it seems like the majority of home runs he hit on average was around in the 30s. Okay, so for the last example, you have a worked out representation of what standard deviation means. It's on average how far the numbers are from the mean, but I'm going to show you how to do this with the calculator. So you can see down here, the first thing we would need to do is calculate the mean. Okay, the mean foot length is 24 centimeters. So this 25, that is 1 centimeter above the mean. This number 22 is 2 centimeters below. This number 20 is 4 centimeters below, and so on. So what we calculate here in this column are the deviations from the mean. But you can see I can't average those deviations. If I add up all those deviations, some are positive, some are negative, they will always add to 0. So clearly we don't have an average deviation of 0. So what we do is we square those differences, but now we've inflated this. So if I add all those up and divide by 1, 2, 3, 4, 5, 6, 7, if I try to divide by 38 by 7 to say this is the average deviation, I've inflated it by squaring all those. So we don't want to do that. We almost do that. To get a sample standard deviation, we divide by 7 minus 1. Population standard deviation, we would divide by 7, but generally we want sample standard deviation. So what do I do to account for the squaring? I take the square root at the end here. Okay, what I want to show you is take these numbers and enter them in your calculator. Let's go ahead and do that now. Okay, so after I enter those in my L1, I'm going to do the same thing I did previously. I'm going to hit Stat, Calculate, and I want the one variable statistics for that L1. It's a new list. So notice what we have here. They give us two measures of standard deviation. We have the SX, okay, which is 2.5166, and then we have population standard deviation 2.33. So the population is where we would divide by 7. When for sample standard deviation we divide by 6. We never really assume that we have the whole entire population. So you can see that's why we got 2.52 as our sample standard deviation. See this 2.52 here? So I wanted you to see how standard deviation is calculated so that you understand what standard deviation means. It's a typical distance from the mean. So let the calculator do the heavy lifting, but make sure you can interpret what standard deviation means. It means that a typical distance from the mean of 24 centimeters is 2.52 centimeters, right? It's the typical distance of each foot length from the mean. That's what standard deviation measures. So remember, if you have an outlier or a really big number, something that is making the mean larger, that's also going to affect standard deviation. Standard deviation and mean sort of go together. If you're measuring the center with mean, standard deviation is a good measure of spread because it measures typical distance from the mean. If you're going to use median to measure center, maybe because the distribution's skewed or there's outliers, you use median, then maybe you want to use the IQR to measure spread.